Welcome, everybody, today. My name is Ana Arias. I am a professor at the Electrical Engineering and Computer Science Department, and I'm also the chair of the Engineering Science program. I have to say that I love this interaction that I have with the students through this program. And I know that every one of you will get to know your faculty advisors really well before you graduate. So today we have prepared an agenda that hopefully helps you to get to know some of the faculty and some of the students involved in this program. I will give you an update or just a of the programs and introduce you to students. At the end, we will have a panel with the current students from all our majors. And our goal today is to leave as much time for questions as possible so that we interact with everyone and we hear what you're curious about, what you're worried about, and everything that must be discussed. So as you know, in this session, we will have students representing the 4 majors of this program. We have energy engineering, engineering math and statistics, engineering physics, and environmental engineering science. These programs are highly interdisciplinary. Throughout your 4 years at Berkeley, you're going to take classes in the engineering department as well in the sciences. So you will get to know students and faculty from everywhere on campus. And really get exposed to a lot of cool stuff. Just a few things to be aware when you start studying at Berkeley. You are all here accepted to Berkeley because you are the best of your class. So everyone that you're going to meet here was the best of their high school. Work really hard to get to Berkeley. Went through a highly competitive selection process, and you did it. So that's fantastic. When you start studying at Berkeley, you will find that the bar is high because everybody is so good. That happens to faculty too. When we come to Berkeley, we all have to work harder because we were all very good. And then we come to a place where the bar is higher. And I personally love that because there is not a single day since I joined Berkeley that I have not been learning. And I am sure it will be the same for you. So I like to start this talk by saying, recognizing that happened to me, Professor Arias. That's happened to me when I went to the university also. And when it happens to you, just look around you, to your friends, and reach out to people that you meet and learn from them. Form groups to study. Even in this online format, you can find ways of learning from others, and look and accept help from faculty and from your peers. And since now more than ever, we go through tough times. Everything is different from what we were used to. So if you do need professional help and you want some counseling, the university does offer counseling, and you can find all the details. Now you can get appointments by Zoom or phone, and you can find all the details here in the link that I'm sharing with you. So I will just say a few words about the freshman curriculum, and then as I go through the majors, I will call out different faculty so that they can introduce themselves and also the students that are representing that major. But at the beginning, when you start studying here, you will be most likely taking similar classes or the same classes, since the curriculum for all majors is quite similar. So you'll be taking all the prerequisites that you need for your upper division, or the basics of math and chemistry, and also physics and some engineering in your freshman year. There are a few things that I like to point out because you can sign up for seminars in the spring and also in the fall. These seminars are a great way of getting 1 credit and get exposure to a lot of different topics that are research topics that are happening at Berkeley. And it's never too early to start learning about the research that happens on campus. So I happen to offer every fall a course that is called E93. This is a course that is only 1 unit. It started off by being a course offered only for energy engineering students. It is a requirement for that major, but I opened up to everyone, and I invite professors from across campus to give talks about their research. And you see here that the schedule is quite varied. I see that there are some mistakes here in the format, but you have, I am the first speaker in that series, and then you have several of the faculty advisors from this program speaking, as well as professors from other departments. You can still sign up since it's an online class. I opened up to as many students as are willing to take it. And I will be recording the talks from the professors, so everybody should have access to the research. The feedback I get from students is that it's a great way of learning about research, and many of them make contacts with the speakers and then end up doing research in their labs. Okay. You will get to know Felicia very well. She is our department advisor. I am sure she already helped you somehow. She's here co-hosting this event. So take a note of her contact, and together with the college advisors, Felicia will help you navigate all the problems or any doubts that you might have regarding the program. So now I'm going to start introducing the faculty advisors for each one of the majors, and I'll ask one of them to give an overview from each major. I'm not sure. I think I have to stop sharing in order for the others to be able to share their video. Is that right, Felicia?
Let me see. Oh, so what I did instead, so we have Professor Von Meyer here. So here she is.
Yeah, okay. Yeah. Do I need to stop sharing, or I don't?
No, you can stay on there.
Mm-hmm. Okay, all right. So go ahead, Sasha.
Great. Well, thank you. I'm Sasha von Meyer. I'm an adjunct professor in the Electrical Engineering and Computer Science department. And my area of specialization is the electric grid. So I came to this personally a little bit from a different direction. My undergraduate degree was in physics here from Berkeley. And so I actually will say that I remember the experience of being a new undergraduate student at UC Berkeley. And it could be a little intimidating. And I really want to echo what Professor Arias said about, reaching out, even in these crazy COVID times, to be sure that we get to know you because we want to help you succeed. So in my own studies, after getting an undergraduate degree in physics, I was a high school teacher for a few years. And then I got my graduate degrees also at Berkeley in energy and resources, which is a really interdisciplinary program. So it wasn't strictly an engineering program. I started learning about the electric grid really more as an anthropologist because I was interviewing the engineers and the operators who make the electric grid work. And that topic has fascinated me because it's such an interesting and difficult technical system, but also because it's so important today as we're having to take action on climate change. So I teach EE 137A and B, Introduction to Electric Power Systems, and I hope to see a lot of you there, maybe this fall or maybe next year. Usually students take that in their junior year. And I don't know, Anna, how long you want me to speak. I think that might just wrap up the quick intro. Any of you should feel free to. I have Zoom office hours on Mondays and Wednesdays. I don't know yet how to post the link to students who are actually not enrolled in my class, but feel free to email me and always happy to talk.
Thank you, Sasha. Do we have other faculty advisors from Energy?
Sure, Scott Moore here.
Hi, Scott. If you could also say a few words about the major, it would be great.
Yeah, sure. Hello, everyone, and welcome to Cal. It's a pleasure to be with you. My name is Scott Mora. I'm an associate professor in civil environmental engineering and also a faculty advisor for energy engineering. Just a few words about myself. I'm originally from the Los Angeles area. I also received my undergraduate degree from UC Berkeley. I arrived in 2002, so you can do the math. My undergraduate degree and my graduate degrees actually were in mechanical engineering. I'm now in civil environmental engineering. I advise for energy engineering. And I was also in the Cal marching band. So if you have any questions when it comes to the Cal fight songs and the proper lyrics, I am your guy. I want to make a couple points. The first point I want to make is for all the engineering science students, if you feel like, what is engineering science? Is this just a hodgepodge of other majors? It's not. In fact, I like to think of the engineering science department as in some ways like the incubator for what future engineering majors will be. In fact, when I was an undergraduate, there was this really weird unknown major that people didn't know what to do with it. And it was called bioengineering, right? And now it's a full-fledged department that exists all over the country and all over the world, right? And so there's a history of that sort of thing. So many of you are in the avant-garde, right? And frankly, other universities look to the engineering science department and say, let's let Berkeley figure out how to do it right, and then we'll copy. So congratulations for being part of this very dynamic department, this very dynamic, innovative department. Energy engineering, just to talk a little bit more about it, I think it's the youngest in the engineering science department. It's grown quite large and quite quickly because by many metrics, the energy engineering industry is the largest industry in the world. Makes sense to have a department on it. And it's especially increasingly important as we start to battle issues like climate change, climate equity, environmental justice. What I really want to say is that we need you, and by being in Berkeley Engineering, you're not just here to find any job that pays okay. That is not the vision or the role that we specifically envision for our students. Namely, we need you to be the leaders, the intellectual innovation, societal leaders that can lead society to the more resilient, sustainable, and equitable world that we all want to live in. So as you begin your career and you go all the way to the end, you're going to start to understand this in a much deeper, meaningful way about what it means to be a Berkeley engineer, especially in energy engineering, especially in engineering science, but just in Berkeley as a whole. And we're really excited to help you grow into that. And I also want to add, don't be too concerned about morphing yourself into who you think we want you to be. We want you to be the most authentic version of yourself and to bring the most authentic version of yourself, because you're going to have the most fun. You're going to have the most impact if you are that most authentic version of yourself. And the people who have graduated from Berkeley have been the most authentic version of themselves in the ways that they've had impact. No one gets noticed if they're just like everybody else, right? They get noticed because they do something different that is important. So delighted to have you and excited to get to know you all more. Thanks, Professor Arias.
Thank you. So Sasha and Scott, you can press the leave button, but you'll still be here on the screen.
Great. And then in this major, you will also meet Professor Frattoni. He is based in the nuclear engineering department, and Professor Zodi, who is from mechanical engineering. And I introduced myself briefly at the beginning. My area of research is flexible electronics. And within flexible electronics, I have worked many years in solar cells and batteries. And I teach E134, which most of you will take, well, all the energy engineering students will take as probably in your last semester, if not in the last year. So I am not an undergraduate from Berkeley. I got my undergraduate from Brazil, where I am originally from. And I did my PhD at the University of Cambridge in the UK. And I moved to the US in 2003 to work in industry. I have 10 years of industry before I became a professor. So you're all welcome, and reach out to us with any questions. I will organize some Zoom meetings for us. Okay. So let's move on to engineering, math, and statistics. I believe Professor Casey is here, maybe Professor Adler also. So Felicia, let us know who will speak.
I'm fairly new to this age. I'm only 20 or 25 years advising the program, but Professor Casey came before me. So I give him to describe the program, and then I'll talk a little bit myself.
Thank you.
Okay. I thought I added Professor Casey, but I don't know where he went.
He says trying to get into the meeting.
Oh.
And then you told him that the meeting didn't start yet.
Right, and then I tried sharing. So Professor Casey, can you try pressing share screen and audio? And then I should be able to add you. Awesome. There you go.
Okay. This is my first time using Hop In. I'm already forgetting how to use Zoom. So it's all new for us too. We certainly would much prefer to be in the room with you and to be in the classroom with you next week. But we have to put up with what we're dealt, I guess. I want to tell you just a little bit about myself and some other things about the program. Professor Adler and myself have been advising in engineering, math, and stat for many, many years. We essentially co-advise. So if you ever have a question about engineering, math, stat, come along and ask either of us. Depending on how you develop as you go through Berkeley, you may want to talk more to Professor Adler or more to me. But you can talk to both of us at any time. I grew up in the Republic of Ireland, which is a little green and rainy island at the western end of Europe. And I came to Berkeley to do my PhD. I intended to go back to Ireland, but actually there were no jobs there at that time. The Celtic Tiger had not arrived. I think the Celtic Tiger left already, so I don't know what I'll do next. I loved Berkeley since the first day I came here. After I got a PhD, I taught at the University of Houston for 10 years, and then I was delighted to get a job back at Berkeley in 1990. And I've been associated with this beautiful program, Engineering Science, ever since. I was chair of the program for some time. Scott mentioned about bioengineering. It was a very exciting time when we developed a bioengineering department, one of the first in the country, out of that in the late 1990s. And I think you can see what's going to happen in the future, that someday there will be an energy department, I believe, a full-blown energy department. So very exciting. Now, the little program that we have, Engineering, Math, Stat, probably will never grow bigger than it is. We have 35 students total. I hope you all get to know each other. You can do that by joining the Society of Engineering Sciences and getting to know other people in the other majors as well, of course, engineering, physics, and energy, etc. So do that. However, something has happened on campus, which is like a huge growth of our program. It took place independently of us, and that's what's called data science. It's a combination of computer science and statistics. It doesn't have as much math as we do, but some of you might find yourselves interested in more in the statistics and data science type of activities. So please do have a good look at that program. What else do I want to say? This program, especially Engineering, Math, Stat, is tremendously flexible. Yes, you do have to take a certain amount of very hard math and statistics, but then there's a whole bunch of other pieces of it that are not determined specifically. It's just called an engineering focus. You may have no idea yet as to what your focus will be, but we will help you develop the focus. For example, it's very popular and obvious, of course, to choose, say, computer science along with engineering, math, stat. We have a lot of our students do that. We also have a lot of students go to Professor Adler's program, Operations Research, which has to do with problems that can be solved by optimization. And he will tell you some very interesting ones that he's worked on himself. But there are other choices you might make too. For example, we rarely have students go and specialize in bioengineering as their focus, but that's actually a tremendously good degree to take. And there are lots of other choices as well, obviously, the obvious ones, civil, mechanical, etc. So the way to decide is to talk to your peers and talk to your advisor, your faculty advisor, and talk to your student services advisor as well. They are tremendously helpful in helping you to decide on your path. A couple of other things I would like to say. I suppose you've been told already about freshman and sophomore seminars at Berkeley. Those are a good way of meeting other people outside of your own major. The setting is usually very small, maybe maximum 20 students. You can take courses in really interesting areas from very brilliant people. For example, I've seen ones this semester on Shakespearean sonnets. I've seen one on the discovery of the Higgs boson. I've seen one on Brazil. So have a look at the list and do try and sign up for one or another of those. And not this semester, but as you go on with your studies, do take a course that's related to mathematics and statistics, but in an area that you might not have ever thought about before. For example, one of our students took a course in neurobiology many years ago and ended up loving that, and actually is a professor in that area now. We didn't mention it before, but these programs in engineering science are specifically designed really way back since the 1970s. They've been specifically designed to help you prepare yourself better for graduate school than if you took a regular program. Now, many of you will go on to graduate school. Some of you won't. You'll go out and take jobs in industry or do a startup or whatever. But we have graduate school, I won't say in the back of our minds, pretty much in the front of our minds. And don't be shocked that we're talking about this on your first day of college. We've thought about it. We've got a program. We've got a plan. So graduate school is out there. And we hope that many of you will go on and get your PhDs. And like Scott said, become leaders in your fields. That's what we want. I think I'll hand over to Ilan now.
Okay. Do I have to do anything?
Just say a few words about yourself, Professor.
Yeah, no, I mean, I don't have to click anything or anything. No.
I don't think so.
Okay, so I will start a little bit like Professor Scott Mora started. He was a graduate student in 2002, and you do the math. I was an undergraduate student in 1964, and I'm not sure you can make the math because that's too long ago. So the way for me to really tell you about the program is where I was when I finished my undergraduate in statistics and economics in Israel, in Jerusalem, in the Hebrew University. Pretty good place. But when I finish, I want to continue. For one thing, I didn't want to get a real work, which I still don't have. So it's a good life. And but I was not satisfied with either economics or statistics in Israel at the time. It didn't have enough mathematics to my way. They talk about more in a superficial way, and I wanted to understand more. And then I read an ad in an Israeli paper that another institution, the Israeli Institute of Technology, the Technion in Haifa, has a program they call Operation Research. And I have no idea what Operation Research is. I went there, and then I find out that actually they use mathematics and statistics in a way that I care about. And for me, the main thing, if you want to get the main thing, I like to solve puzzles. It's always like solving puzzles. And I always like to understand exactly what we are doing. Once we have the assumptions and the models, we let the map take us wherever it goes, and the statistics. And if the outcome is not relevant, we change the assumption and start again. But once you have the model, you want to follow the mathematics. And I always loved that. And then I came to Berkeley as a professor after being in Stanford. Some of you might hate that part of me, but I was a PhD student in Stanford. I came here, and about 20 years after I'd been here, I discovered this program. I didn't know about engineering, about science engineering, and definitely not about math and statistics. And once I saw it, I'm still there, and that was in the early 90s probably, when I joined the program, because for me it's a dream program. It's even better than OR. There is hardly anything which is not purely what I like. In OR, you still have to take courses that you may or may not feel comfortable with that. But if you want to continue, especially at least into a master's degree, and as Professor Casey say, if you want to do data science is really optimization and statistics. I think you're better off taking those programs and then learning about the specific courses in data science than go to data science. You understand deeper and better what's going on. And that goes for the other subdiscipline. So I envy all of you that you have the chance to be in that fantastic program, and I hope you make the best out of it. By the way, as it was said, I was in the IOR department, and my field is optimization. So I'm doing a lot of optimization, but I'm very familiar with statistics also. And I love data science because it falls very neatly into what I understand and do. And with that, welcome all, and I leave the floor for somebody else.
Thank you, Professor Adler. Okay, so now I would like to introduce the faculty advisors from engineering physics. Felicia, I think you are the one who knows who is in the call.
Right. So we have Professor Atwood here, and then so for now, Professor Casey and Professor Adler, you can press the leave button on the top right of your screen. You'll still be in the session, but it'll just hide you from. And then I saw Professor Wu on here, but he just don't know where he went. Do you want to try? Oh, there we go. Great. Here we go. So Professor Wu or Professor Atwood, whoever would like to begin talking first.
You go first.
I think you're muted, Professor Wu.
Okay, well, maybe I'll go ahead then in the meanwhile. So I'm David Atwood, and Professor Wu and I are here representing engineering physics. So for those of you who are in the major, you know it's basically an applied, known elsewhere as applied physics. You take courses in physics and some engineering and other technical electives to create a professional path that interests you. And for the first year or two, most of the courses are in common with everybody else, but you'll start to get a sense of what it is you enjoy doing and where you think you want to go with this. For myself, I'm involved in lasers and X-rays and nano imaging and things like that. But applied physics has many, many avenues, and our students, maybe some fraction go on to graduates, many go on to graduate school, some in engineering, material science, some go to pure physics. It depends on how you choose your electives, and Professor Wu and I are always available, and you can contact either of us, and we'll answer your questions. And we've been doing a lot of Zoom meetings over the summer with people, and we continue to do them. So if we can help you, please let us know, or if you have any questions, please ask questions. Thank you. So Professor Wu, you seem to be muted.
I don't know.
Oh, it's not muted. I can actually hear, but
Just
not
very, very far. Yeah.
Oh, okay. You hear me now?
A little better.
I turned up the volume. That's why I can hear you. Yeah.
Oh, okay. Sorry. Can I speak now?
Yes.
Okay. All right. So first, a little bit about myself. My name is Junqiao Wu. I am a professor in the Material Science and Engineering department. I am an advisor in the engineering physics major. I grew up in China and I studied physics in my undergrad degree. And then I came to UC Berkeley for my PhD degree. I got my PhD degree in the year 2003, and then I went to the East Coast. I went to Harvard, did my postdoc over there. And then I came back in the year 2006 and became an assistant professor in the material science department. I became a engineering physics advisor, I believe, about 4 years ago. Together with Professor David Atterwood, we advise students from this wonderful program. My own research field is semiconductors. I study the physics, the growth, the purification, the application, the device fabrication of based on semiconductors. I teach a class that is semiconductor materials. It's called MSE 111 in the material science department. That many of you, once you get into your sophomore or junior year, you will probably take. If you want to challenge yourself a little bit more, you can also take MSE 223, which is the graduate version of this semiconductor class that I teach in the spring semester fall semester every year. Okay, so as Professor Atwood said, engineering physics is really a very flexible and very broad and very interesting major, and I congratulate every one of you to be admitted into this program. We basically learn physics and use the basics of physics to solve engineering problems. As Professor Casey said a minute ago, that many of you will be interested in going to graduate school after this. And I want to tell you that many engineering physics major went to graduate school in very different departments, like to physics or to electrical engineering, to chemistry, to material science, of course, right? So therefore, this program would prepare you for a lot of opportunities in the future. Just my the former chair of my department, the material science department, Professor Mark Asta, and he actually is a professor now in the material science department. He got an undergrad degree from your program, the engineering physics program, many years ago, and he told me that that this program, prepared him like no other program. He would not be able to become a professor in material science and do so wonderfully well if he went to, like, say, a real physics program, right? So I am also a chair of another PhD program on this campus. It's called Applied Science and Technology Program, which Professor Atterwood is one of the founding fathers of that program. And that program is like a graduate version of the engineering physics that we educate PhD students, train them to do research in all kinds of applied science and applied physics and mathematics program. So if you are interested into going to graduate school, maybe your second year or third year, please feel free to come to talk to me. I have a lot of experience and a good story to tell you. All right. So again, congratulations. And my office is in the Hearst Mining building, the best looking building on campus. I hope that once the COVID-19 is gone, you can stop by my office and we can chat about it. Thank you.
Thank you, Dave and Junqiao. So you guys can press the leave button on the top right. You'll still be in the session, but it will just hide you from the screen.
Very good. The students from engineering physics will also have Professor Salahuddin as one of their advisors. Professor Salahuddin is based on the electrical engineering and computer science department. He's a physicist by training, like myself. And he does a lot of research that is very related to this program. He's new, and please reach out to him also. Okay, and then our final major, I believe Professor Nelson is here to talk to you about environmental engineering science.
Okay, so I'm just checking before I launch in. Can you see and hear me?
Yes, everything looks good.
Great. Okay, well, let me join my colleagues in extending a very enthusiastic welcome to all of you. It's so great to be finally starting this semester. I was also an undergraduate at UC Berkeley, so there seems to be a theme or a trend among our engineering science advisors. That was a long time ago, and this major of environmental engineering science did not exist. And if it had, I'm pretty sure it would have been the perfect major for me. So I, like many of the professors you've heard from, I didn't study engineering as an undergrad. I studied biophysics, and that's because I really wanted deep engagement in the sciences. And then I discovered that the ways that I wanted to apply my science were best, I would have the best skills to do that if I also studied engineering. So I transitioned to my engineering studies as a graduate student. So I kind of designed my own environmental engineering science pathway. And so I'm just really happy for all of you that we have this major that you can get started right away as an undergrad. So what is environmental engineering science? So in short, we study water, air, and soil systems. And the history of human development, and in particular the Industrial Revolution, is that we've sort of sacrificed the environment and also human health enable to develop human civilizations and technologies. But we no longer think that way. We no longer think that that's a trade-off that's worth making. So our goal now is to design our infrastructure, the infrastructure that supports our human civilizations, in a way that does not degrade the environment. And especially today, recognizing the challenges of our changing climate, that we design our infrastructure in a way that doesn't contribute to climate change and also helps to mitigate the impacts of climate change. So in environmental engineering science, you'll develop a strong foundation in the basic sciences, physics, chemistry, and biology, and of course, math. More and more, computing and data science tools are essential. So we really encourage you to delve deep into that skill set. And then you're going to complement that with studies in the environmental sciences, so water, air, and soil systems, as well as ecology. But what makes this major really unique is the engineering toolbox that then you're going to bring to working with all this foundational knowledge, and in particular, quantitative analysis. So environmental scientists study a lot of the same systems, but the hallmark of our engineering analysis is making that analysis quantitative, as well as developing innovative solutions. So we work not just on understanding the impacts of pollution on the environment and human health, but how do we actually solve those problems? How do we bring innovation to develop new technologies and new solutions to address the challenges that we're facing? So like the other engineering science majors, this one is incredibly flexible. It's very multidisciplinary, and you have a lot of room to identify the specific topics that you want to focus on. Environmental justice is an area that a lot of our students are very interested in, and so that's another type of classes and focus that you can bring into this major. Like you've also heard from my colleagues, this is the environmental science majors, the engineering science majors are great for preparing you to go on to graduate school. So I wanted to share a little bit about research areas. We encourage all of you to get involved in research as undergraduates. whether you decide you want to go on to professional practice or graduate school. And some examples of that in environmental engineering science are really at the forefront of confronting the challenges that we're facing, like right here, right now, today. So air quality, environmental engineers are deeply involved in understanding the impacts of wildfires and including indoor air quality. So how do we actually quantify the types of pollution that we're being exposed to for those of you that are in the parts of Northern California that are being impacted by the wildfires right now? How do we improve indoor air quality? How do we quantify those impacts on our human health, and how can we prevent them? How can we reduce them? In the area of water quality, California is sort of perpetually experiencing drought these days, and that's sort of the reality that we live in. So how do we create more circular water systems so that we can take less and less fresh water from the environment and leave that to support our ecosystem? So now it's possible to turn wastewater directly back into drinking water, and that's one of the topics that my research group works on. We're also working on COVID response research in the water area. So the SARS-CoV-2 virus that infects people also is excreted by people that are infected. And so we can detect the virus in wastewater. And so we've launched a program to monitor the virus in our campus's wastewater as a way of trying to minimize transmission on campus, as well as for the whole Bay Area region. We're working with our wastewater utilities all across the region and public health authorities. So in short, environmental engineering scientists are extremely responsive to challenges that we are currently facing. And just one last thought I'll leave you with in terms of framing our discipline is we view waste as a resource. There's really no such thing as waste. Everything is a resource, and one of our goals is to try to extract that value. One other thing about the major and about how to get settled on campus is that you have a lot of common with students in civil and environmental engineering, which is another major in the college. And a lot of those students are also emphasizing environmental engineering. So I would encourage you to join the student chapter of ASCE, that's the American Society of Civil Engineers, because you'll find other students that you share a lot in common with there, and it's a very active student. For example, there's a competition team for environmental engineering that's really fun and hands-on, and you get to interact with other students. And so that's something I encourage all of you to become part of at some point during your time with us. All right, so that's environmental engineering science.
Thank you. Thank you, Kara. Okay, so next introductions for everybody are your college advisors. I heard Olivia at the beginning of the call. I'm not sure if Brian was also able to attend. But if you are here, please, Olivia and Brian, introduce yourselves, and so that the students get to meet you. For sure, you are going to interact with both of them a lot, looking at your courses, looking at credits that you need for graduation, and they are an amazing resource that is here for you.
Thank you, Professor Arias. So hi, my name is Olivia Chan. I am the advisor for environmental engineering science, energy engineering, and engineering math and statistics. And my colleague, Brian Jones, is your ESS advisor for engineering physics. So basically, you will come to us if you aren't sure, if you have a question and you aren't sure who to ask, feel free to come and ask us, and hopefully we can direct you to where you need to go if we can't answer the question. We are the ones who will monitor your progress towards your degree. So just to make sure you're taking all the classes that you need to in order to graduate. We will also be the ones to direct you back to your faculty advisors if there are questions that we don't know the answer to, or we feel that your faculty advisor would be the better person to answer it. So again, welcome. I'm sure that Brian and I will be talking to all of you in our drop-in advising tomorrow. And definitely feel free to email us or set up video appointments. And yeah, go Bears.
Thank you, Olivia. Okay, everybody, be nice to Olivia and Brian. Okay, and then finally, the last part of our agenda today is the student panel. We have students that are in the majors, and they are going to be here to answer any questions that you have. And I am going to stop sharing so that they can introduce themselves. And I guess Felicia is going to open the floor to questions also. Let's see if that works. Okay.
So if you're in the student panel, go ahead and press share your screen and audio, and I should let you or allow you to be on the screen. And guests as well, you're able to chat in your questions and we'll answer appropriately. And Anna Claudia, if you don't want to be on screen, you'll still be in the session and you can also hit leave if you'd like. I know Daniel's here. You can also help out too, Daniel, if you'd like to. And then, so we have almost everyone. Awesome. Great. Okay, so this is everybody. Before we get questions, I guess, or if there's no questions yet, maybe you guys can all introduce yourselves first. Let's start with Derek.
Okay, sure. Hi, everyone. My name is Derek. My pronouns are he, him, and his. I'm a rising senior studying environmental engineering science, and I'm also minoring in marine science. And I'm originally from Torrance, California, just 30 minutes south of Los Angeles.
All right. I'm Aditya. I'm a senior in both engineering physics and engineering maths and statistics. And I'm originally from New Delhi, India. So I'm happy to talk about, why I chose to double within engineering science and the benefits that I think I've got out of that.
Hi. I am majoring in energy engineering, and I'm a rising senior as well. And I'm originally from San Diego.
All right. Hi, my name is Claire, and I am also a senior. My pronouns are she, her, and hers. And I am from Irvine, California. I'm currently in engineering math and stats and minoring in EECS. Yeah.
Awesome. So it looks like we have our first question. And you guys can just choose how you want to answer. How easy is it to balance academics? Curriculars and academics.
Sure, I could start off. So what I found is that in college, you have so much free time. You literally can do whatever you want with it. And in terms of balancing academics and extracurriculars, it's totally up to you how much time you want to spend with each of those components. Some students want to just focus more on the academic sides. Other students want to have a more college experience, going out and having fun with friends. The great thing about Berkeley is that or I guess it's kind of tough now, but usually you could go to other places such as San Francisco and stuff like that. And you just really have to organize and plan your time schedule. So, what I like to do is I set a certain amount of time each day to do my homework and study for classes, but then I also set a certain amount of hours each week to do something fun, whether it is playing tennis or chatting with my friends on Zoom.
Just to add to that with a bit of an engineering science specific perspective, one thing that the faculty speaking earlier touched on was, I think the engineering science majors in general have a lot of flexibility. So you can absolutely start to tailor what you're working on to things you're interested in. And then it won't feel this is a bit of a cliche, but it won't feel like as much work then. It won't feel like a burden when you really feel like you're doing things you want to be doing.
Anyone else want to give their input?
I guess I can share a little bit as well. So I think for me, in the very beginning, I definitely kind of take on too many units because, like transitioning from high school to college, we're just kind of like, oh, we can take like 4 or 5 classes. That's fine. And I later learned that it is much wiser to kind of start off with a manageable workload. And it really comes down to like what type of classes you're taking. So just being able to kind of strike that balance of the number of technicals you want to take and just kind of what type of extracurricular you really want to spend your time doing. For me specifically, I find myself very interested in teaching. So I've been tutoring and or part of the computer science mentors. And also now I'm part of the CS61B core staff. So I think just taking the time for you to actually find something that you're interested in and sticking with it would really help you kind of strike the balance between everything you want to do.
Plans for after graduation, do you feel?
Yeah, I guess before we answer that question, Daniel, do you want to introduce yourself first too? And then you can move on to Professor Casey's question. I think you're muted, Daniel. No luck. I know he mentioned he was having some technical difficulties. So does anybody, we can start, let's see. We can start addressing your plans after graduation. Do you feel that the ES program prepared you well for it?
I'm happy to talk about this one because I actually think engineering science gave me a really unique perspective on what I want to do. So I've pretty much settled on I want to pursue a PhD in astrophysics. And the fact that I'm an engineering science major rather than a physics or astrophysics major meant that I could take classes that were relevant to projects specifically that I was doing. So I worked on control systems or telescope optics. And what really helped me is, as part of engineering physics, I ended up taking the EE classes on optical engineering and control systems, like in the semester right before that, which meant I could get into the project and know like a lot more than someone with just the physics background. So in that sense, in the sense of I have a broader idea of the kind of technical background I can draw upon, I think engineering science has been great. And there's also other aspects of your faculty advisors are super knowledgeable, and you get a much broader sense of what you can do, which is, I think, the best thing you can get out of undergrad is a broad sense of what's out there, what you could do later on in your career. I really appreciate that about engineering sciences.
And then for me too as well. So going in as a freshman, I chose environmental engineering science as my major because I liked the environmental science side, but I also like math and physics. But I honestly had no idea what I wanted to do with my life going in. But through the engineering science program, I was really able to take classes that like seemed really interesting, and I was really able to explore my different options and different careers that I could take with environmental engineering, whether it be like air and water like remediation. And one thing that I'm really interested in now is in ecological engineering. So working a lot with like the ecology and engineering side, I'm really interested in ecosystem restoration. So restoring rivers and streams to promote salmon migration below dams and stuff like that. That's really interesting. And now I hope to pursue a 1 year's master's. I don't really want to go the research side because I hope to eventually work as an environmental consultant for like an environmental consulting firm or the Department of Fish and Wildlife. And I really think that the engineering science department is preparing me for these careers because for especially for like environmental engineering, it's not only important to have that science and physics background, but also the environmental side too. And I was really able to take a lot of environmental classes outside of the College of Engineering, including in the College of Natural Resources and the Department of Environmental Science Policy and Management, but also Earth and Planetary Science and even integrative biology too, which is really great.
It's also important to emphasize that I also didn't really know my freshman and sophomore year what I was fully intending on doing. I had a really long phase where I thought I'd be a mechanical engineer working on simulations. And so the ability of engineering physics to let me pursue that, and then not exactly switch tracks so much as customize my track more as I developed interests, was really helpful.
Daniel has somehow multiplied, and I don't know what's going on.
It was me.
There's 3 of you.
Can you hear me now?
Oh no.
There's 3 of me. Okay, I don't know why that is.
That's okay.
Okay, only one of them turned off. Okay. What was the current question?
Right now, the question was your plans after graduation and how you feel the program prepared you for it.
Okay. Right now, I've been looking at internships and jobs within more of a mechanical engineering side of things, and that's still a work in progress. Also, shall I do general introductions? I do that.
Yes, general introductions, and if you'd also like to talk about SES, that'd be awesome.
Alrighty. So my name is Daniel Fries. I'm a senior studying math and statistics, and I'm the president of Society of Engineering Sciences. And who is SES? SES is professional and social club, specifically for engineering science students. As you may have already been able to see, all these majors are quite small in numbers, and SES hopes to provide a place for engineering science to get to know one another, to network, to form study groups, and many more things. How can I connect? That is a wonderful question. So we have a Piazza page. Piazza is a forum that is generally used with classes, but we also have one. And if you have any questions about courses, schedules, like hey, should I take this class for an elective? Piazza is our Piazza specifically is a wonderful place to ask that and receive pure feedback. The engineering science representatives, they'll be there to be able to answer questions. This doesn't of course substitute for actual going to your engineering science your ESS advisor, but it can be a good first step.
Thanks, Daniel. Our next question is, have any of you pursued minors during your time here at Berkeley, and how the time commitment for balancing major, minor, course load, and any other activities?
Okay, I guess I can take this one because I am currently minoring in electrical engineering and computer science. So I think for me, because of the flexibility that the engineering math and stat program, or I guess engineering science program in general, kind of provides, I was able to kind of optimize the my undergrad requirements in such a way that they kind of happen to fulfill multiple requirements. You obviously have to work this out with your advisor. So if you are interested in a minor and or double majoring, you should definitely, keep that in mind and talk to your advisor once you do have your mandatory meeting in the beginning of the semester. And I think for me, in terms of time commitment, in the beginning it was kind of rough because I was really bad at asking for help and getting the right resources that I need to finish my, courses in a timely fashion. But I think over time I really learned kind of the community that is CS and the community that is math, depending on what class I was in, and really learn how to, balance out working in groups and just knowing how to work more effectively. And I was still able to have a lot of time to, you know, hang out with friends and like participate in some extracurriculars such as SES now and Cal Alumni Student Association. And as I mentioned earlier, teaching, to name a few. But yeah.
Yeah, cool. And for me, I'm minoring in marine science. When going in, I knew I wanted to, I really like the ocean. So doing something with marine science was always just kind of like on the back of my head. At one point, I actually considered doing a simultaneous degree with marine science, meaning that I would get my major in my home department, College of Engineering, but then another degree at the same time in a different college. So in this case, it would have been College of Letters and Sciences. But I realized if you were to do that, the College of Letters and Sciences has a 7-course breadth requirement. Ours is like, I think we have to take like 4. But those additional courses, I realized that it would make my schedule pretty packed, and I didn't really want to have to put that on myself. So I decided to minor in it instead. And what I found was that a lot of our lower division courses, such as our maths and our physics, actually overlapped with the marine science minor requirements. So in that sense, a lot of my classes overlapped, and there are just less classes that I had to take. And you're also allowed to overlap one of your major requirements with one of your minor requirements too, which is really nice as well. And it's really great because I kind of like worked out my schedule so that I'm only taking 4 classes each semester, and I've never taken above 15 units, which I've really liked as well. And I've been able to balance all of my major coursework, my minor coursework, as well as just having fun with like clubs and just hanging out with friends.
Yeah, for me, I started out maybe thinking about minoring in math, but then realized I liked it enough and I wanted to do enough of it that I just wanted to double major, which is a big commitment that I wouldn't necessarily recommend. It's just on a case-by-case basis, and I think it worked out for me. Like, I love all the coursework that I'm doing, but maybe you're not the type to want to take a lot of coursework. You want to invest more in research or clubs or teaching or any of the other great things you can do with your time here. So I really liked a decision of like going really far into the physics, really far into the math, and seeing how both of those come out in engineering applications, seeing how I can apply the math that I learned to research in unexpected ways. I like just the breadth of knowledge that I've been able to gather through it, but I wouldn't say it's for everyone. One thing I'd absolutely encourage everyone to do is take classes that aren't necessarily like within what you think you might like. Just try new things. It's a really great time for it. Like when I mentioned earlier that I'd taken the feedback control systems class, it was because I'd previously taken the signals and systems class, EU120, just sort of on a whim because I knew some of my CS friends were taking it, and it seemed like a nice extension to some stuff that I'd learned in math class. And that led to a whole like chain of other classes that I took that led to me now being a TA for the probability and random processes class. So a lot of these things work out nicely, and just like if you let yourself explore new interests. That's another.
Thank you. So I think that we did answer. Did I miss Ivan's question? No, we did.
No, I think we answered.
So our next question we have from Antonio: are all of our classes going to be on Canvas? If not, how do we find where they'll be located? So how have you guys been able to navigate your classes and the platforms that they'll be on?
Generally, the professor will let you know what platform they're going to distributing through. A lot of the times it is going to be B-courses, which I think is the same thing as Canvas. But sometimes courses like I think CS department will have, or like CS classes will use a different website, but the professor will always provide that information.
Thank you, Brittany.
Yeah, I know for one of the classes. I can be heard, right?
Yes.
Okay, awesome. I know one of the classes I'm enrolled in right now, Math 128A, the Canvas website hasn't been released yet.
Daniel, I think both of you are muted right now.
I can hear Daniel.
Oh, sorry, that might just be me.
Okay. So some of your classes might not have a Canvas page yet. I would wait like until maybe tomorrow, and if the professor hasn't like released the website or otherwise emailed you, hey, we need the course website, I'd probably recommend contacting them, because Zoom is probably going to be what's used for lectures for most, if not all, professors. And obviously you'll want to have received those Zoom links. That way you can actually view the lectures.
Thank you. How has SES helped you connect with others in your major? I'm not sure if everybody is in SES that's in the student panel, but or if you guys want to talk about how you've been able to connect with other people in your major.
I think that being a part of SES is definitely a good idea, especially in your first 2 years, because at least for me, my freshman and sophomore year, my classes didn't really, the other energy engineers were taking my classes, but they were very large lectures, and I didn't really see anybody from my major. So it wasn't really until junior and senior year that I was taking smaller classes where I was with a lot of energy engineers and really became a part of that community. So I think if you get involved with SES right away in your freshman and sophomore year, then you can kind of jump right in and make immediately without waiting for your coursework to kind of overlap.
And then for me, for my freshman year, we actually had SES had a mentorship program. So I was assigned an upperclassman mentor who was in my major with similar interests. And from there, I was able to meet with them. And then I was able to ask them questions about their major and just like classes and then just like life at Cal. And I found that really helpful. And we're actually hoping to create a similar mentorship program this year. So stay tuned for that.
Thanks. How about what types of student orgs have you been involved with at Cal? How has this enhanced your experience in regards to your major?
I'm sorry, you can go.
Okay, so I've been involved with 2 clubs in like some level of depth. My freshman and sophomore year, I was on a rocketry team called STAR, which I really recommend. It was a great time. That was when I was in my probably going to be a mechanical engineer phase. And that was great to meet a lot of like passionate people across a bunch of different majors, try out the different flavors of engineering, that kind of thing. And then for the past year and a bit, what I've been involved with is ULab, which is undergraduate lab at Berkeley, where I mentored a team on an independent research project. This was by the time I'd like done a bit of research myself, and I sort of knew how it worked enough to like help younger students through it. And so right now as well, I'm running their curriculum so that people learn like basic research literacy and the inter-programming that you need to do research in physics and astronomy. It's helped me a lot because it does give me like other people that I know in the major for like navigating, you know, what should I probably take when. Like in both clubs, I met EP majors for sure. I'm not sure about EMS. There was probably at least, yeah, I think there was another EMS major, but I met other EP majors, so I definitely had someone to talk to about that from there. But I think the bigger benefit was I got to meet a whole range of passionate people across a lot of different interests. I guess my general theme today is talk to a lot of people, try a lot of things, have new experiences.
I am a part of the Irish Dancers of Berkeley, and I'm actually running that club right now. And happen to have any Irish dance experience, we would love to have you. Go check us out on CalLink. And I think it is a good idea to, I mean, there are a lot of really wonderful clubs that are very specific to engineering, but I think it's also a good idea to maybe look at something that's even more, extracurricular, not related, so you can kind of meet people outside of the College of Engineering, and also just give your brain a little break. And yeah, I've really enjoyed being for that reason.
Okay, I think I can add to that a little bit as well. I definitely echo Diaz's sentiment about like trying different things. Like a fun example is the Cal Alumni Student Association that I've been part of since freshman year. In fact, I met Derek, who is also on this panel through that, and he's a wonderful person. And I think the thing about the Cal Alumni Student Association that we're able, with the alumni, we're able to really work with people that it's outside of engineering, because once you're taking classes, a lot of times you get tunnel vision into your own field. And I think for me, it was very beneficial to actually talk to people who are in vastly different majors, and really gave me new perspectives about, the way to approach problems or problem solving, conflict resolution, and all that good stuff. And another thing is I love teaching. So I also met Aditya through teaching last summer for CS61B. So it's just like being able to find kind of communities of people with similar interests is definitely like one of the best ways to de-stress, in my opinion. So yeah, 10 out of 10, recommend all of the above.
Yeah, and for me, I'm part of Engineers for Sustainable World. So we're a club focused on sustainability, and we participate in a lot of projects that help create the Berkeley community, both the Berkeley community and surrounding community, more sustainable. So I worked on 2 projects. I helped create a floating wetland in a local lake to remediate the effects of harmful algal blooms on the lake's ecosystem. And now I'm currently working on a team that's creating a bioswale or like rain garden kind of thing to capture excess stormwater runoff from one of UC Berkeley's buildings. And in that sense, I was really able to actually apply a lot of the ecological and engineering concepts that I've been learning in class to this project, and I thought that's really interesting. And as Claire mentioned before too, I'm also part of the Cal Alumni Student Association. The Cal Alumni Student Association isn't really like directly related to my major, but going in, I wanted to have a club that I would, like a more social club where I could just go hang out with, meet friends totally unrelated to your major. And I kind of recommend that too as well. It's great to be involved in clubs that are related to your major, but I also encourage you to just do clubs that are just really fun and very social, especially with everything on Zoom too. It's a great way to meet new people and really find your community here at Cal. And what I found was that when you join these clubs, Berkeley is like a really large university. We have 30,000 students, but participating in these clubs and meeting these types of people and really finding your niche here, it makes that large community feel really small. And I really like that about it here.
Thank you. So let's answer these next 2 questions, and then after that, we'll be moving into breakout sessions shortly for all of you guys to meet within your or into your individual majors. In a few minutes, somebody will input the different links so it's easier for you guys to access your individual sessions. But I think these next 2 questions are great for the whole audience here. So how is SES meeting this semester?
Another great question. Be meeting via Zoom. If you join the Piazza sometime during this week, we'll have a when to meet posted to gauge when students are available. That way we don't schedule a meeting and, everyone happens to be in class during that time. And yeah.
And then oftentimes the SES group also sends me emails, and I usually disperse it to all the people in the majors. And then our last question for now, did you all have any worries or doubts coming into the engineering program your freshman year on how you would be able to handle coursework and college life, etc.?
Yeah, I mean, I was definitely nervous. I think everybody's nervous coming in, and with some amount. I think a really good thing when I was taking the 93 with Professor Arias, my freshman year, I think somebody from the advising department came in, and I remember they said undercommit and over-deliver. And I think that's kind of a good thing to keep in mind. So don't stretch yourself too thin. And the things that you do commit to really, really go full. And so with your coursework, read the textbook. If optional problem sets are posted, try to do them really as much as you can do to understand the material, and avoid procrastination as much as possible. And I think that's a good way to really stay on top of things.
Yeah, and for me too, going in, I was really hesitant that I even made the right decision to come to Cal, and it wasn't through GBO and a lot of like the first week of classes where I met a lot of great people and was exposed to a lot of the resources to really help and set us up for success. So there's a whole bunch of like tutoring resources on campus, free tutoring resources actually too, offered through the Student Learning Center. They offer a lot of tutoring by current Cal students who took these classes. That's really great. Like for example, like your chemistry, your physics, your math. And I found that really useful as well. I used it for one of my general biology courses my first semester here. And that helped me a lot too as well. And then there's also tutoring offered through the Welcome Center. It's CAEE. I think it's like Center for Access for Engineering Excellence, something like that. CAEE, something like that. But they also do tutoring as well. But I found that the main resource, like a really major resource that a lot of students don't take advantage of, are office hours, professor office hours, and your graduate student instructor office hours. Like they have office hours every week where you can literally just go into their office, ask them questions about classes, homeworks, but also just life in general. I remember going into one of my solid mechanics classes last semester to my professor's first office hours. I asked him some questions about what we learned in class, but then the conversation just entirely shifted to like, so Derek, what do you want to do with your life? And he was just giving me really great life advice. And I was just like, this is a great resource. And I really, really encourage you to take advantage of these office hours because these people are here to help you, and just take advantage of that.
Sure. Okay, so we have one more message from Scott. I think, Scott, you can share your video again if you wanted to make or say it through video.
Yeah, hi everyone. This is a really good discussion, and I think the advice you're getting from your fellow students here is fantastic. So I just want to supplement by making one more point on this, and that is you all represent the best that your high schools and community colleges have to offer, and you've demonstrated an ability to academically, right? I think the most important thing besides knowing the resources is actually this growth mindset, this idea that, Berkeley engineering, it's not easy. And, as a result, that's why our students are so excellent. But the most important thing I want to get across here is that the techniques and skills that allowed you to be successful in high school and community college, those aren't enough in Berkeley engineering. Right. And I learned this myself when I was going through as a student. That is, in high school, for example, you probably didn't spend extra time with your teachers to ask questions. You probably didn't meet up with classmates virtually or physically to work on your homework together, et cetera, et cetera. There are important new skills that I think it's super important that you realize, okay, I need to level up my ability to do well academically. Prior, I may not have gone to office hours, as Derek was saying. Prior, I didn't form study groups because I didn't really need to. And it's not just about doing well in class, quite honestly, it's training for life. Engineering is truly a team sport. None of the biggest engineering innovations came from someone being by themselves at home. They asked questions from people who could give them advice. They worked with their colleagues, their peers. They explained things to each other. They taught each other. So I think the most important thing besides knowing about these resources is just this mindset of, okay, now we're going to level up. Thanks for allowing me to share.
Thank you, Scott. So we're going to be moving into breakout rooms now. Again, I'll have to paste it individually, but I just wanted to say thank you so much to the student panel. You guys will be meeting with students that are directly in your major. So I think this will be a good opportunity for you guys to develop these relationships now, just so you guys can meet each other. Yeah, so I will also stay in this room if there happens to be any technical difficulties or anything, or if you guys wanted to ask me individual questions, but I'll be here until 1 o'clock. So enjoy, everybody. Thank you.